नमस्कार मित्रांनो, लेट्स लर्न अँड ग्रो टुगेदर या आपल्या युट्यूब चॅनल मध्ये सर्वांचं हार्दिक स्वागत आहे। आपण अल्कोहोल्स, फिनॉल्स आणि इथर्सचा सेकंड पार्ट पाहतोय। त्याच्यामध्ये अल्कोहोलच्या प्रिपरेशन मेथड आपण पाठीमागच्या भागामध्ये पाहिल्या होत्या। आता प्रॉपर्टीज ऑफ अल्कोहोल्स आपण पाहणार आहोत। मेनली दोन प्रकारच्या प्रॉपर्टीज आपल्याला माहित आहेत की फिजिकल प्रॉपर्टीज ऑफ अल्कोहोल्स अँड केमिकल प्रॉपर्टीज ऑफ अल्कोहोल, दॅट मीन्स रिएक्शन्स ऑफ अल्कोहोल्स। परंतु त्याच्यावरती आधारित क्वेश्चन कुठले असू शकतात आणि बोर्ड क्वेश्चन मध्ये कसे क्वेश्चन येतात हे आपण पाहणार आहोत। इम्पॉर्टंट क्वेश्चन ऑन द फिजिकल प्रॉपर्टीज अँड केमिकल प्रॉपर्टीज ऑफ अल्कोहोल्स। तर त्यातलं पहिलं फिजिकल प्रॉपर्टी दोन क्वेश्चन हमखास विचारले जाऊ शकतात। हा क्वेश्चन अल्कोहोल्स हॅव हायर बॉइलिंग पॉइंट दॅन इथर्स, एक्सप्लेन। 2 मार्क्ससाठी हा क्वेश्चन येऊ शकतो। पाठीमागे एकदा आलेला आहे आणि त्याचे आन्सर कसे लिहायचं थोडक्यात हे आपण पाहणार आहोत। व्हाय अल्कोहोल्स आर सोल्युबल इन वॉटर, हा सुद्धा क्वेश्चन आलेला आहे 2 मार्क्ससाठी। राईट अ नोट ऑन फिशर हिस्टरिफिकेशन, 2 मार्क्ससाठी क्वेश्चन आहे। डिस्टिंग्विश प्रायमरी, सेकंडरी अँड टर्शियरी अल्कोहोल्स बाय युजिंग लुकास रिएजन, हा क्वेश्चन 3 मार्क्ससाठी आलेला आहे। डिहायड्रेशन ऑफ अल्कोहोल्स, प्रायमरी, सेकंडरी अँड टर्शियरी अल्कोहोल्स बाय युजिंग different concentration of H2SO4 or in presence of alumina at a different temperature, हा सुद्धा क्वेश्चन 3 मार्क्ससाठी आलेला आहे। 2 मेकॅनिझम आपण पाहणार आहोत। त्यातलं हे एक मेकॅनिझम आहे डिहायड्रेशन ऑफ अल्कोहोल्स इन प्रेझन्स ऑफ कॉन्सन्ट्रेटेड ऍसिड टू फॉर्म अल्कीन, हे सुद्धा मेकॅनिझम 3 मार्क्ससाठी विचारण्यात आलेला आहे। अतिशय इम्पॉर्टंट अशी 3 मेकॅनिझम आपल्याला या चॅप्टर मध्ये पाहायचे आहे। त्यातलं एक मेकॅनिझम आज आपण पाहणार आहोत। तर हे इम्पॉर्टंट क्वेश्चन काही 2 मार्क्ससाठी, काही 3 मार्क्ससाठी आताच्या क्वेश्चन पेपर मध्ये हमखास पाहायला मिळतील असा माझा अंदाज आहे। तर त्यातला पहिला क्वेश्चन आपण पाहूया। अल्कोहोल्स हॅव हायर बॉइलिंग पॉइंट दॅन इथर्स अँड एक्सप्लेन व्हाय अल्कोहोल्स हॅव हायर बॉइलिंग पॉइंट दॅन इथर्स। तर अल्कोहोल्स आणि इथर्स याच्यामध्ये आपण प्रॉपर्टी मध्ये जर पाहिलं तर फिजिकल प्रॉपर्टी मधली ही इम्पॉर्टंट प्रॉपर्टी आहे। तर त्यातला आन्सर जो पहिला पॉइंट आहे, अल्कोहोल्स फॉर्म हाय हायड्रोजन बॉन्डिंग, हाय टेंडन्सी टू फॉर्म हायड्रोजन बॉन्डिंग बिटवीन मॉलिक्युल्स and large number of molecules are associated together by hydrogen bonding and large amount of energy is required to break these hydrogen bonds. Hence alcohols have higher boiling points. And if we observe the ethers have do not ability to form hydrogen bonding. No molecules of ethers are associated together by hydrogen bonding. The only force of attraction between ether molecule is one role force of attraction, and hence ethers have low boiling point than alcohols. How alcohol molecules are associated together by hydrogen bonding, and we can show alcohol molecules like this: ROH, ROH, ROH। हे 3 मॉलिक्यूल में अल्कोहोलचे काय रिप्रेझेंट केलेले आहेत। आपल्याला माहिती आहे हायड्रोजन वरती डेल्टा मायनस चार्ज, ऑक्सिजन वरती डेल्टा प्लस, डेल्टा मायनस ऑन ऑक्सिजन, डेल्टा प्लस ऑन हायड्रोजन, डेल्टा मायनस, डेल्टा प्लस, डेल्टा मायनस and delta plus. Hydrogen bonding is nothing but it is a electrostatic force of attraction between hydrogen atom of one molecule and electronegative atom of another molecule. These are alcohol molecules, and these alcohol molecules are associated together by type of bond which is known as hydrogen bond. Such a type of hydrogen bonds are present and high energy is required to break hydrogen bonds. Hence alcohols have higher boiling point. तर अल्कोहोल आणि इथर मध्ये जर स्ट्रक्चर बघितलं आपण तर इथर्स आर रिप्रेझेंटेड एज ROR and there is no hydrogen atom. If only oxygen atom is there, but intermolecular hydrogen bonding is not possible in ethers, and hence ethers have low boiling point, alcohols have higher boiling point because energy is required to break hydrogen bond. Extra amount of energy is required to break these hydrogen bonds Hence alcohols have higher bonding bond. दोन पॉइंट मध्ये आपल्याला हे आन्सर लिहायचं आहे की यांच्यामध्ये हायड्रोजन बॉन्डिंग आहे, इथर्स मध्ये हायड्रोजन बॉन्डिंग पॉसिबल नाही. दुसरा जो क्वेश्चन होता, व्हाय अल्कोहोल्स आर सोल्युबल इन वॉटर. एक्सप्लेन व्हाय अल्कोहोल्स आर सोल्युबल इन वॉटर. The solubility of alcohols, it is also due to the formation of intermolecular hydrogen bonding between alcohol molecules and water molecules. Also, alcohol molecules and water molecules are associated together by force of attraction, which is known as hydrogen bonding. Delta minus charge is on oxygen and delta plus charge is present on hydrogen. And such a type of molecules comes together by hydrogen bonding, like this another alcohol molecule, hydrogen, delta plus, delta minus, delta plus, delta minus. That means water molecule is associated with alcohol molecules. There is the intermolecular force of attraction between alcohol molecules and water molecules, and this type of force of attraction is again hydrogen bonding. That means alcohol molecules have ability to form hydrogen bond with water molecules, and due to which these molecules are soluble in water. And ethers are insoluble because ethers, organic compounds, generally insoluble in water, but alcohols are soluble in water. This is the reason, that is hydrogen bonding. You have to draw a diagram and you have to write the force of attraction which is between alcohol molecules and water molecules is hydrogen bonding. Intermolecular hydrogen bonding takes place between alcohol molecules and water molecules. As the size of R increases, solubility decreases due to hydrophobic nature of this alkyl group. Hence, the higher alcohols are sparingly soluble in water, but lower alcohols like methanol, ethanol are completely soluble in water. असे दोन क्वेश्चन आपण आता पाहिले की solubility and boiling point. Then we will move towards the chemical properties of alcohols, that is the reactions of alcohols. रिएक्शन मध्ये सर्वात महत्त्वाचे आपण इस्टरिफिकेशन ची रिएक्शन सुरुवातीला पाहिली की राइट अ नोट ऑन इस्टरिफिकेशन ऑफ alcohols. Alcohols reacts with carboxylic acids, acid chlorides, and form their corresponding esters in presence of concentrated acid. We'll see first the general reaction ROH plus RCOOH in presence of concentrated H2SO4 formation of ester takes place. याला आपण R डॅश म्हणूया. यातला OH आणि यातला H असं रिमूव्ह होतं. H2 is removed, OH of alcohol and H of acid. Sorry, OH of carboxylic acid and H of alcohol is removed. In this case, we will rewrite the reaction. RC double bond OH we will first write, and then HOR opposite ROH, and his OH of acid and H of alcohol get removed as H2 molecule, and it is experimentally proved by labeling oxygen atom. If this oxygen atom is labeled by O18, it's an isotope, and we will find H2O in the oxygen which is labeled in the H2O, and hence we get RC double bond OR as the product. This is the ester, and this reaction is known as Fischer esterification. It is known as Fischer esterification. The important is that OH from acid and H from alcohol get removed as H2O, and this reaction takes place in presence of concentrated H2SO4. The role of concentrated H2SO4 is to remove H2O molecules, and as soon as H2O is formed, it is removed from the reaction mixture because this reaction is a reversible reaction. H2O and ester react together and form acid and alcohol, and to make this reaction in the forward direction, H2O, as soon as H2O is formed, it is removed from the reaction mixture. We have written the general reaction. You can write its example. The acid is CH3COOH plus alcohol CH2CH3OH, that is CH3CH2 ethanol and acetic acid reacts together and form in the presence of concentrated H2SO4 and formation of CH3C double bond O हा OH आणि IH निघून गेला, CH3C double bond OO CH2CH3 इथिल ऍसिटेट हा प्रॉडक्ट आपल्याला इथं मिळतो. हे त्याचं एक्झाम्पल झालं फिशर एस्टरिफिकेशनचं. प्लस H2O is removed in this reaction like this Fisher esterification reaction. Note, and carboxylic acid and alcohol reacts, again acyl chlorides and alcohol reacts. That means this is the important reaction of alcohols. Alcohols can combine with carboxylic acids and also acyl chlorides to form esters, and this reaction is known as Fisher esterification. आणखी एक आता महत्त्वाची रिएक्शन आपण जी पाहणार आहोत त्याच्यामध्ये डिहायड्रेशन ऑफ अल्कोहोल्स. त्याच्या अगोदर लुकास रिएजंटची 3 मार्कची रिएक्शन आहे. हाऊ विल यू डिस्टिंग्विश प्रायमरी, सेकंडरी अँड टर्शियरी अल्कोहोल्स बाय युजिंग लुकास रिएजंट. या रिएक्शन साठी 3 मार्क काय तर प्रायमरी अल्कोहोल, सेकंडरी अल्कोहोल आणि टर्शियरी अल्कोहोल, these reacts differently with Lucas reagent. What is Lucas reagent? The mixture of concentrated HCl and anhydrous ZnCl2 is known as Lucas reagent, and it has the ability to react with primary alcohol, secondary alcohol and tertiary alcohol. Tertiary alcohol reacts easily and not require anhydrous ZnCl2 with concentrated HCl, they only react. Secondary alcohols reacts with Lucas reagent and form turbidity after few minutes. Tertiary alcohols immediately form turbidity. Secondary alcohols after few minutes, and primary alcohols on heating, prolonged heating. बऱ्याच वेळाने आपल्याला प्रायमरी साठी टर्बिडिटी मिळते. टर्बिडिटी काय मिळते त्याचं एक रिझन आपल्याला बघायचं. फक्त सुरुवातीला डिफरन्स काय आहे. टर्शियरी अल्कोहोल रिएक्ट्स इझिली, सेकंडरी अल्कोहोल्स आफ्टर फ्यू मिनिट्स and primary alcohols after prolonged heating with HCl and anhydrous ZnCl2. That means if we take example of primary alcohol CH3CH2OH plus HCl in presence of anhydrous ZnCl2, that is the Lucas reagent concentrated HCl and Lucas reagent. These alcohols are soluble in Lucas reagent, but the product formed CH3CH2Cl plus H2O. This alkyl chloride, that is ethyl chloride, is insoluble in a Lucas reagent and form turbidity after prolonged heating. That means if we heat ethanol with Lucas reagent, after prolonged heating, we will get turbidity due to the formation of ethyl chloride. And if we take secondary alcohol CH3CHOH, same reaction takes place. This is secondary alcohol. It reacts with HCl in presence of anhydrous ZnCl2 and form CH3CHCl CH3 plus H2O, only replacement of OH by Cl, and here isopropyl chloride is formed. This reaction takes place after few minutes. Prolonged heating, after few minutes we get turbidity. And for tertiary alcohols, tertiary alcohol example CH3CH3OH plus HCl in presence of anhydrous ZnCl2, formation of OH is replaced by Cl, tertiary butyl chloride, and anhydrous ZnCl2 is not required and heating is not required. Immediately tertiary butyl chloride is formed, and hence we can distinguish primary, secondary and tertiary alcohol. You have to write all these reactions, and you have to only write this product is formed after prolonged heating, this product is formed after heating for few minutes, and this product is formed immediately when Lucas reagent is added to tertiary butyl alcohol. And why turbid solutions are formed? These are formed due to the formation of corresponding alkyl chlorides, and hence this reaction is used to distinguish primary, secondary and tertiary alcohols. Very important reaction to remember, the distinguishing reaction of primary, secondary and tertiary alcohol. Again we will write the last reaction of this session, and it is a dehydration of alcohols by using concentrated H2SO4, and different concentration of H2SO4 is required for the dehydration of primary, secondary and tertiary alcohol. If we take primary alcohol CH3CH2OH, and dehydration takes place in presence of concentrated H2SO4, phosphoric acid, anhydrous ZnCl2, alumina. These are dehydrating agent. That means it is a beta elimination reaction. We have already studied in this reaction in 11th standard. Beta elimination means hydrogen atom from beta carbon and OH from alpha carbon get eliminated, formation of unsaturation. Carbon-carbon single bond is converted into carbon-carbon double bond, as it is a elimination reaction. And for primary alcohols, 95% H2SO4 is required, and temperature is 473 Kelvin at high temperature and having 95% concentrated H2SO4. If alcohols are heated, ethanol is heated in presence of 95% H2SO4 at 473 Kelvin. We will get CH2 double bond CH2 plus H2O. It is a dehydration reaction. Dehydration means removal of H2O. And for primary alcohols, requirement is 95% H2SO4. And for secondary alcohol, if we take example of secondary alcohol as isopropyl alcohol, we require only 60% H2SO4 and 373 Kelvin temperature, and formation of H and OH are removed from the adjacent carbon atom. Beta elimination reaction, two types of beta carbon atoms are there. Two beta carbon atoms are there, hence you can remove hydrogen atom from any of the beta carbon atom. If we remove hydrogen atom from this carbon, we will get CH3CH double bond CH2. Hydrogen atom from this carbon and OH from this carbon, formation of alkene. Whenever elimination reaction takes place, alkene is formed, propene is formed from propanol. We have already prepared propanol from propene. Now preparation of propene from propanol, and it is the dehydration reaction of alcohols. And last reaction, that is CH3C, CH3, CH3OH, tertiary butyl alcohol on heating with 20% H2SO4 and at 363 Kelvin, less temperature and less concentration of H2SO4, formation of isobutylene CH3C, CH3 double bond CH2. Isobutylene is formed, that means 2-methylpropene is formed. Hence this reaction is also very important. The dehydration can take place by using alumina also. If alumina is used, Al2O3 is used, instead of 95% H2SO4, 673 Kelvin temperature is required for primary, for secondary 573, and for tertiary 473 Kelvin temperature. Only this is the difference. If instead of 95% H2SO4, that is concentrated H2SO4, 60% H2SO4, 20% H2SO4, we can use alumina as a catalyst for the dehydration reaction. We can also use H3PO4, phosphoric acid, for the dehydration. Hence, what is the action of these reagents on ethanol, isopropyl alcohol, tertiary butyl alcohol? You can write this reaction, or many times this reaction is asked that write the dehydration reaction of primary, secondary and tertiary alcohol by using different concentration of H2SO4 or at different temperatures in presence of alumina. Yes, we have to write this reaction for 3 marks, each reaction for 1 mark. We will see mechanism in the next lecture.